work on in class exercise 1 from chapter 13, which is on page number 25 of your handout, and we will solve one problem, which is P13-1 question B, and we will work on this problem, which is problem 13.10. So let's begin with this. The 10 kilogram block is subjected to the forces shown. In each case, determine the velocity when time t is 2 seconds, and if velocity is 0 when time t is 0. So none of this block is moving when time t is 0. That's called the initial condition, and we need to calculate the velocity of the block at 2 seconds if the forces as shown in the figure are applied. So these are two different problems, A and B. We will work on problem B. Once we work on problem B, you'll be able to solve this yourself, problem A. Now these are the rectangular coordinate equations of motion that we will consider for this in class exercise, where sum of forces in x is mass time x acceleration if particle has motion in x acceleration. Same goes for y and z. Now remember, if the particle is moving in this direction and speeding up, that means its velocity increases with time, then acceleration is in the same direction. But if the particle is moving in this direction and it's slowing down, then this acceleration is called negative acceleration, minus ax, or you can also draw this in the opposite direction, but with the positive number, positive ax, because the particle is moving here, but it's slowing down. So then acceleration is in the opposite direction. It's called deceleration. Okay, so let's apply. So first step, we'll follow the same steps as we have discussed previously. First step is we define our coordinate system. So we say that x-axis is right, y-axis is going up, positive respectively. Now next step is we draw free body diagram. So we indicate the externally applied force, which is 20 times t. So force is function of time. Now another force that we need to include here is W equal to mg, which is weight of the block. Now the block has weight, block has 10 kilogram weight. So it's 10 times g, that is the 10 multiplied by 9.81. So this is actually 98.1 newtons. That's the weight which is acting downward. Now block is resting on a surface, so there is normal force. Whenever anything is resting on a surface, there is a normal force. So that normal force is acting upward. Now this force moves the block in the right direction, and friction opposes that motion. So friction acts in the opposite direction, which is mu times normal force. Now in this problem, we have not been given the value of mu, so we can, for this matter, we can neglect the value of friction force, assuming that the applied force is much larger than friction force. So friction is not reducing any force here. So we can only include this force and not the friction force. And this is what you should do, is when you don't know mu, then you can make a note here, assumption that because mu is not given, neglecting friction. If mu is given, then yes, consider friction force. Okay, so these are the different forces. Now the block does not have any acceleration so we have three equations. So first let's apply sigma f equal to y in, and going up is positive, is may. The block does not move in vertical direction, so ay is 0, so it's m times 0, which is 0. And the forces that we include here are normal force minus weight force. That means normal force is equal to weight force. This is one first step of the problem. Now the next step is we apply sigma f x equal to max. Going right is positive, because that's our coordinate system. Going right is positive, and horizontal forces are 20 times t, that's the only force, equals 10 times ax. That means ax is 2t. Now at this stage, do not substitute the value of time because acceleration is function of time. Do not substitute the value of time. However, integrate and calculate, derive the equation for velocity because we are interested to calculate the velocity of the block at 2 seconds. So we know that acceleration is dv by dt. That means dv is equal to a dt. I have rearranged the equation, and now it's time to substitute the limits here. So it's 0 to v dv is equal to 0 because see, time when velocity is 0, when time t is 0, that is given in the problem. So that is the lower limit condition. Now when time t is t, what is the velocity that we don't know? So we'll substitute that here. 2 and acceleration equal to we will write 2t. So continue solving that problem here. So integral 0 to v dv is nothing but v, and integral on the other side is 2t square by 2, and then the limits of integral are 0 to 2. So this will get cancelled. So at the end we get v equal to t square only. So now we know the velocity as a function of time. So at t equal to 2 seconds, velocity is 2 square, which is 4 meters per second. And that's our final answer. Okay, so once again, look at the approach. We have defined the coordinate system. We have drawn free body diagram. We haven't drawn kinetic diagram, so we can draw that here. So kinetic diagram is the block indicating the acceleration of the block 10a. So this is label that as FBD and label this as kinetic diagram. Okay, and then apply these equations of motion in y direction, x direction, get the acceleration. Because acceleration is not constant, it's function of time, we need to do this integration and derive the function for velocity and then substitute time to get the velocity. Now we'll work on the second problem from this in-class exercise 13.10. Let's read the problem statement. The conveyor belt is designed to transport packages of various weights. Each 10-kilogram package has a coefficient of kinetic friction mu equal to 0.15. If the speed of the conveyor is 5 meters per second and then it suddenly stops, determine the distance the package will slide on the belt before coming to rest. So it's not clear here, the direction is not given, but we can assume that this is the direction the block is traveling to. Okay, so the conveyor is rotating in counterclockwise direction and the block is traveling going from right to left. And for that case, when conveyor stops all of a sudden, then the block does not stop as per Newton's first law of motion, but it will slide on the conveyor for some distance and then come to rest. And we need to calculate how much distance the block slides on the conveyor before coming to rest when the belt stops all of a sudden. Okay, so let's define the coordinate system. X-axis going right is positive and y-axis going up is positive. And then the next step is we draw our free body and kinetic diagram for the block. So FBD of the block is we draw the block, W weight acts downward, W equal to mg, normal force acts upward. Now when the conveyor belt stops and the block slides in the left direction, then the friction acts in the opposite direction between the conveyor and the belt. This is where the friction acts. So we draw this as friction force FF, which is mu times N. Okay, and that completes our free body diagram. Now corresponding kinetic diagram, the block moves in the left direction. So this is the motion of the block, but it's actually slowing down. So the acceleration that it experiences is in the opposite direction, AX. Because this acceleration is because slows down. Okay, and this is our kinetic diagram. So we have drawn both free body diagram and kinetic diagram, and now it's time to apply equations of motion. So sum of forces in y direction equals m times y acceleration. Going up is positive. There is no y acceleration of the block. Block does not move in vertical direction, so this is 0. And this force is normal minus w. That means normal force is equal to weight of the block. Next step, friction Ff is mu times normal force, which is mu times weight, which is mu times mg, because w is equal to mg. So that's the equation for the friction force. Third equation is sum of forces in x direction is equal to mass times x acceleration, and we assume going right is positive. So the only horizontal force from our free body diagram is this force, friction force, and that's acting right direction. So Ff is equal to corresponding acceleration is ax, that is also going right because block is slowing down. So m is equal to ax. Now we can substitute this equal to mu k m's time g is equal to m ax. So m and m divide by m on both sides will get it cancelled. So we get ax is equal to mu k times g. Mu k is 0.15 and g is 9.81 gravitational acceleration. So we get 1.47 meters per second square. And this acceleration is not function of time or position, so we can say that this is constant. So when acceleration is constant and we need to calculate the distance traveled by the block, we can use one of this kinematics equation. So we have three kinematics equation, and remember this equation page will be given to you for the exam. Now constant acceleration, there are three equations, and we need to calculate the distance traveled by the block. We should not use one of these two equations because those equations have time in them, and we do not know how long it takes for the block to slide and stop. However, we can use the third equation because it is independent of time. Now v0 is the velocity of the block when conveyor stops, which is same as the velocity of the conveyor. V is the final velocity of the block when it's, or package, when it stops moving, which is 0. Acceleration we already have calculated, and this is what we need to calculate, distance travel. We can define the position s0 as the position measured from the point where the conveyor stops moving. So let's apply this equation to our problem. So v square is equal to v0 square plus 2ax s minus s0. Now final velocity of the block is 0, initial velocity of the block is 5, but we substitute minus 5 here, and the reason for negative is because our coordinate system is going right, positive, and the conveyor is going left. So velocity of the conveyor is negative. So that's why we substitute minus 5 here. Acceleration of the block we already have calculated 1.47, so we can actually substitute that number here. So it's 2 multiplied by 1.47. Now the distance is measured, the distance traveled by the block is measured from the moment the conveyor stops. So that is S0, and related to that we are measuring this distance S. Now this distance is in negative direction of X, so we substitute minus S for that. Okay, and then when we solve this equation, we get S equal to 8.50 meters. Okay, and that's the final answer. So here is our entire solution. Coordinate system, free body diagram, kinetic diagram, equations of motion, and then the final solution, kinematics. Okay. So we have started with kinetics, and we solved the final step using kinematics. Thank you.